Hello everyone, welcome to today's workshop on game design. So we have a lot of people here who are interested in game design and development. So welcome to this workshop. This is not a formal workshop or anything. This is going to give you an introduction and hands-on experience. So if you have downloaded the UpBG thing which I had sent you earlier, then you'll be able to work with me. So today's workshop is about game design, and we'll be doing the game design experience with a software called as UpBGE. So, what exactly is that? I'll discuss in few minutes. So, now before we start, uh, I hope all of you play games. Is there anyone who has not played computer games or anything? Okay, I doubt there would be anyone, at least if not on computer, you might have played it on the mobile and other things. So game development is a very, very interesting field, and it is very exciting thing also to work with. And there are a lot of opportunities in game development also. So before we get into the game development part, many people have this assumption that game development requires programming. So is it true? Anyone of you think does game development will require you a lot of programming, or game development is only for programmers? Anyone thinks that game development is only for programmers, or you have to be a computer science student or something like that? Laksh Sharma. So Laksh, why do you think game development is only for programmers and computer science people?
I think it is for both the programmers, computer science people, and for the graphic designers or creative side people.
Okay,
It can be done by both.
okay, great. Okay, so what Laksh feels that it is for both. So when we talk about game development, what exactly is game development? Let's talk about it. Many of you might have seen animated movies, right? So in game development cycle, or the whole game development process is similar to developing a animated movie. If it is a very big game, like games like Free Fire, you might have seen PUBG, and a lot of other computer games are there uh, on different kind of machines, like Sony PlayStation is there, Xbox is there, and huge games are there. So these games, you might have noticed, are like an animated movie, but the big difference here is that you are the main character, one of the characters, and you can actually control the outcome of the whole story that is going on. Fine. So usually when we talk about game development, there is a story, or there is a planning behind it, and then there is a main player around it, and then there are important aspects, are rules and regulations for the game that you can play. So game is a kind of interactive animated movie. Of course, nowadays the graphics have improved so much that they look almost realistic. So in game development, there are multiple aspects involved. One of the aspect which is directly visible to you is the graphics. Fine. So if you plan to get into a game development industry or something like that, the point is that it's not necessary that you have to be a programmer only, because the first thing that you see is all graphics. So one important aspect is the people who are good into graphics. Fine. People who are good into graphics, they can be a part of these game development team. I'm talking about real big game development companies are there, who are developing games and all. They need these kind of people. So we have this, graphic developers are required, then 3D modeling people are required. Fine. Like if your game is about a car race game, so you have to design all those beautiful cars out there. Sometimes to make it very good or looking it very realistic thing, those cars are to be designed, and they take a lot of time. So 3D modeling comes into picture. So like Chirag had asked me that I am doing Maya, so what is the scope? So one of the scopes is that you could be a 3D model developer. Fine. And then in our games, when we are talking about from 3D modeling, certain specific animations are required, some storylines are to be created. These are done via animation. Apart from this, for certain games, people need to have understanding of physics. Like when we are talking about a game, car racing game, then physics comes into picture, fine. Like if in physics there has the concept of friction should be known. When you accelerate, what should happen dependent upon the weight. And like in certain games, a player is moving, walking around, and what happens is lot of wind is blowing. So how fast the player will move against the wind, with the wind, these kind of concepts are to be taken. So if you have certain understanding of physics, then it becomes easier to develop. Or if you are planning to take up the whole game development as your career, fine. So understanding of physics, mathematics comes into picture. And then finally the usage of AI, not the AI which we are used to, like chat gpt and all. Not, there are AI engines. Like when you are creating multiplayer games, you have an enemy or co-racer is there or something like that, and that co-racer is, say, the computer. So there is a computer based AI available. Those AI modules or engines which are available for the game development platforms, they will create your opponent's intelligence, how they will work, and so on. So understanding of a bit of that kind of AI is required. And overall, so this is a huge industry, fine, or huge thing, where when we talk about making big games, fine, a lot of people get involved into it. Anyways, apart from this, for today's session, do we need to know programming? Fine. For today's session, we are not going to do any kind of programming directly by writing the code. Fine. So we will be using an interesting interface which will let you create your games much more easily. Okay. So for game development, a lot of different platforms are available which we can use and work with, where certain of them are based on complete coding, certain of them are based on mix of coding and automation, and certain of them are completely free of coding. But I'm not going to keep you in any kind of confusion or anything. uh, After a certain point, if you really want to take up game development, you should learn coding. And one of the programming languages that is there is Python. Python is a programming language that is developed for anyone and everyone. See, I myself, being from a computer science background, I have worked with different programming languages, and Python is one of the programming languages anyone can learn, irrespective of their background, computer background, or anything. It has been designed in such a way. So, if you really want to get into game development, you may be interested in Python. And on that point, I might take up a session on Python uh, in some upcoming workshops or something, just like this workshop is there. I will be conducting a lot of free workshops in upcoming days. Fine. So maybe I could take a session on Python, introductory session on Python for non-computer science people. Computer science people can also join, but anyone who's interested in programming, they can do programming. Believe me, I have met a lot of people in my life who are not from computer science background or anything, but they are very good at programming. Anyways, that said, let me share my screen and we will have a look at our interface that we are going to work with. So let me just share my screen.
Can we talk a little bit about open source software?
Okay. Okay. Fine. So there is a point about open source software. So most of you might be knowing about open source software, right? How many of you already know about open source software? Yes. I think many of you might have heard about open source software. So open source software is a concept where the software gives you a certain kind of freedom. They are not restrictive, and you can get download these softwares, modify these softwares, and share these softwares with your friends legally. They do come with their own licenses, and that license is called as the GNU GPL license. Fine. Many people have this concept that open source software does not work, is not good, or something like that. So open source software is a great concept where a lot of software is available under this particular thing. In fact, today your mobile phone industry is providing you a lot of mobile phones with a lower cost is because of open source software concept itself, because the operating system and most many other software that you use in your mobile are open source. Fine, that reduces the cost of your software. So open source is another big concept. We can have a discussion about that also later on, but today's interest is in this particular game development thing, and we will be getting into the game development part now, rather than I keep on discussing and boring you with all other aspects. I have given you a bit of overview of these things. Now before we get into this, I'm just going to show you a list of open source games. So if you see on my screen, I've just searched for open source game engines. So there are a lot of game engines which you can use. So what exactly is a game engine? It's a development environment in which you can develop your games. Fine. So the game engine which I am using is UpBGE. I will explain about that in a few minutes. These are a lot of other game engines, out of which this GODOT, it's Godot, it's pronounced Godot, something like that. And this is again an open source game engine. If you are interested in a bit of programming and all, you can go to this particular website or just for search for Godot, and you will be able to develop very interesting games. But this is primarily more based on programming. This is programming oriented. This is one of the very good game engines. Apart from that, we can see here is a huge list of other game engines which are being shown up over here. We will be working with UpBGE. Why we'll be working with UpBGE? The reason is fairly simple, that UpBGE provides us a internal game engine which basically lets us set the game logic in a very easy manner without into getting into actual coding. See, you will be doing some programming, but you will not realize it. Fine. So let's get into that particular thing. People who might have used Unity, or there is one more. It was listed here somewhere. Unity, similar to Unity. Anyways, so people who have used Unity, they might find this work similar today. Now, what exactly is required when we want to develop our games via UpBGE? So first of all, what is UpBGE? Now, UpBGE is basically Blender only. The Blender 3D thing that we saw last time, UpBGE is Blender only. But what has happened over a period of time is that Blender used to have this game engine thing. Means there was a part in Blender in itself which was used for developing the games, fine, or setting up the game logic and creating your game. So Blender primarily is a software for 3D modeling and animation. So the Blender organization somewhere around 2015 decided that they will not continue with the game engine part. So it was called as BGE, that was the Blender game engine. And somewhere around, I think 2017 or 18, Blender decided not to continue with the game engine. So there's this one person called as Tristan, and some organization along with them, they have continued working with this. So if you go to the UpBGE's website, you can find the details of that. What are the exact dates when it happened? What I remember is around 2018 they stopped, Blender stopped the support for this. So these people, what they do is, since Blender is already open source, they take the existing Blender and they continue to manage the game engine part in the Blender. Fine. So what happens now is this, our Blender becomes our 3D modeling environment itself, what we had done last time, our 3D modeling environment itself, and it gives us this added game engine to us, with which we can add logic to our game setup over here, and we can try out our games or create complete games over here. Fine. So that is what is the concept of a game engine. It's a complete development environment. Now the advantage of using UpBGE, if anyone has used Unity, Unity is also a game development environment. It is not open source, as I think we might have noticed over here. Unity is written as proprietary over here. Fine. So it's not open source. This MIT license, BSD license, GNU GPL, Artistic, and most of these licenses are open source licenses. When it says proprietary, so it is not open source. Anyways, so the point is, Unity gives you this game development engine. Unity is a game development engine, but the only thing is, when you use Unity, all the 3D models, design, background, everything you have to create separately. That means either you will use Blender, Maya, or some software to create your scene, model, and everything, which will be imported into Unity as a setup, and then you will create your game logic into that. Once the game logic is there, you can test it, create the whole game, and export it. If you are using something like UpBGE, then you can create your models directly over here, because primarily this is Blender 3D, and you can directly assign the game logic or game programming to this particular piece of system. Fine. So this is our environment. Now I will just restart this for you. Right? I will just restart this. So I have downloaded UpBGE and created this icon over here. So here, this is your splash screen. This is your 3D area where we are going to work with our 3D models. This is our outliner. This is properties area. And this is supposed to be your part, which is where we are going to set up the logic. Now, if you start, most probably you might be seeing this timeline. People who were there in the last workshop, they might be seeing this particular screen over here. Fine. This is timeline, which is used for animation purpose. The thing you have to do is, if you are seeing timeline and not the logic editor, you simply click over here on this icon and convert this under scripting. You will see there are multiple things, and there is a logic brick editor. Right. This is what is there needed to add any kind of logic into our system or to develop the whole game. Fine. Now, in the world of game development, the most difficult part or aspect is to come up with a concept of a new game. Fine. So if you plan to start or develop a new game, you will have to think of some kind of very interesting aspect of the game. So think about it. If you have to plan some new game, what you will come up with, because there are thousands of games that are already developed. The other thing is, in game development industry, is to create a game with the similar concept. Like you might have seen a lot of car racing games are there, shooting games are there, and like there is a Free Fire game, there is a PUBG game. Both have the similar concept. But some people find PUBG better, some people find Free Fire better, and maybe there might be others also. So what is the difference that you are providing is the interface, interactivity, graphics, and all. So one of the ways of coming up with a new game is using a same concept, but how good graphics are there or what new functionality you can provide could be a way of developing the games. Okay. So those are the few aspects. So how do we start developing our games in this particular system, and how easy it is going to be? That's what we are supposed to see. So how many of you are planning to go along with me? You're going to try it out during the workshop? Okay. So few people are there. They have raised their. So hopefully you have already downloaded Blender 3D and if sorry, UPBGE, and this particular thing should be your logic brick editor. Fine. So I'll explain you what logic bricks are, what are the concepts and other things. So first of all, few things that we need to understand. This is our Blender environment, which I had explained earlier. Now this is a free open space. A basic concept of physics has to be understood, is that there is gravity and let me show the z-axis over here. So the gravity actually works from top to bottom. Your gravity is acting this way. So if you have a player, suppose as usual, let's delete this guy, add our favorite monkey over here. This guy will be our player for most of the situations. Now if this is our player, fine, and there is no plane below the player, fine, the player will just fall down infinitely because there is a gravitational pull in the negative z direction. So whenever we are going to play a game or anything or start a game, generally what we will need is a surface on which our game will reside, so that our players don't fall off and they keep on falling infinitely anywhere. Fine. So let's do try that out. Let's add a mesh called as plane and let's scale this. Fine. If you are not very comfortable, click on the mesh. There is this scale tool. Fine. And simply scale the mesh from this over here. Fine. So I prefer my keyboard shortcut, so I'll just say scale it 10 times. So this becomes my basic working area. Okay. Fine. This is the basic setup we have here. Now I'll just give it some kind of simple color so that our whole event does not looks very boring. Let's make it greenish because we'll assume that it is the ground, and let me put it in material preview mode. Fine. This is too brightish green. Let's make it a bit dull. Okay. And our monkey, let's give some color to the monkey, and let's make it blue, more noticeable over here. Fine. So this is our ground on which the monkey can move, and this is the ground, this is the monkey. Now we need to learn how to move the monkey basically. But before that, how do you play the game? To play the game, we simply have to press P and the game starts. Of course, there is no logic over here right now in the game, so nothing will happen. Now, if you might have noticed, I just discussed about gravity, right? I discussed about gravity. Do you notice something is wrong? Something is wrong with the gravity right now. Can anyone guess what is wrong over here? Like I will grab this monkey and place this guy over here. Fine. And if I play the game, do you think something is wrong over here? Monkey is floating. Yes, the monkey is floating. Very correct. So these are the few basic things we need to understand. While starting with our setup, we have to assign some physics. Means we have to tell the system what kind of environment is this. So by default, what happens is that our objects that are there here in the system, they have a physics static. Static means they will stay wherever they are. Fine. Let me just apply the scale to this as usual. Now the monkey which is there, this has to be static because this is our ground. Fine. So this is the world we are creating for the monkey, and we don't want this to fall down. So this is static, and this monkey should not be static because we want it to move. So there is a concept of physics which tells our game engine or game system that how this object will behave. Fine. Physics means like it could be a soft body, it could be a rigid body, Fine. It could be static, means something which stays wherever it is. The idea is that when these things fall down, how they will interact with the other object. Okay. So we first need to change the physics of this object. So let's see from where we can change the physics. With the object selected, here we have the physics tab where this is particles, this is physics. Fine. In the tabs we have physics properties. So over here, these ones which you see over here, fine, the button type of thing, force field, collision, cloth and all, these are the physics which are used by Blender internally for simulations. Okay, these are used by Blender internally for simulations. And here, this is the game physics. This is what we are interested in right now. So the physics type, you can notice here is static. We will convert it to dynamic or rigid body. So let's see what happens when it is dynamic. Now I have put it to dynamic. Now my system knows that this is a dynamic body. That means it can interact with speed, it can fall down and all. So if I play this, now you see it falls down and it stays on the floor. It interacts with the floor. Okay. Now, when we set our objects as dynamic physics, you will notice, see, if you have actually a wooden monkey made like this, there's a wooden monkey made like this, when it falls down, what you will expect? Will it stand like this? Will it stand like this? It will actually tumble. It will fall down. Fine. Like, let's see, if I rotate my plane like this. Okay. Now, if I play this, what you will notice is the monkey is falling down along with the plane. Fine. You can press escape to come out of that game testing. It falls down. It just moves in the same state it is. So the dynamic physics does let it work under gravity and other aspect. You might have noticed that it bounced a bit. So whatever effects are required with a solid material, it is working like that. But it has one interesting aspect about it, that they don't tumble. That means it will not fall like a rock, or based on its shape, technically it should fall down. Fine, it should tumble. So if you are having a game player, generally if you have a game player like this of a weird shape and you just want it continuously standing, then we keep its physics as dynamic, so that we have all the physics interactions and other things taking place properly, but we don't want it to fall down. If you have objects that are there and when they fall down and they should tumble, like real aspect, fine, so you will have to set their physics as rigid body. So I have set the physics of this object as rigid body now. So now see what happens when I play this. Now you see it is falling in a more realistic manner. So this is the rigid body. There are more physics also, but with our time limitation, let's not get into that. For today's purpose, this rigid body and dynamic physics are more than enough. So this is one aspect of the game. When we are developing the game, we have to keep these points in mind, that there is going to be gravity. So like if you are creating a game and some player is jumping off the different buildings, so weight of the player, what kind of physics the player has, what is the gravity. Like you might have played this long back, this game was there, Angry Birds. Fine. In Angry Birds, there was when you would fire the catapult, the bird would fly off on a trajectory and fall down. So this is all the part of the physics. And in one of the parts of Angry Birds, it was shown that they are on a different planet and the gravitational pull was different. So by default, in this game engines, the gravity is set for Earth's gravity. So all the objects like 1 kg mass object will interact with the Earth gravity style. So those settings you have to keep in mind while you are developing the game. If there is some wind and other things, how they will interact. So once I set something to dynamic or rigid, and setting the predefined values, wind speed, gravity and all, your player will automatically interact with those things on their own. So here we can do it from our interface which we are using. In programming, we have to set these things manually, but it gives us a higher control over that. But anyways, today's our interest is that we should be able to develop this small game at least. So this we have understood, that we need a plane, fine, and we need our player over there, and we can set up this. So is this understood, this simple concept? Okay. Now, the next thing that you want to do in game development is to make sure that your object can move around. Right? It could be a car, it could be a uh, monkey, it could be whatever is there. The object should move around. If I play this game, this object comes and sits over there is of no use. So the first thing is we should be able to make our player move around. Fine. So just to have some fun, what we are going to do is I'm just going to add some, not circle, let me add some mesh, say cylinders. Okay. And I will leave this cylinders as static, right? So this becomes a kind of place for us where we can work with. Let me grab this monkey, not the light, the monkey. Let's place it here. Now, what we want to do is when we play the game, we should be able to move the monkey on our own. So how do we do that? For that, we are going to use this logic brick editor. Fine. So before we get into the logic brick editor, we need to understand certain very interesting concept over here. The concept is called as sensors and actuators. Fine. So sensor term, everyone might have heard sensor, might have heard of sensors. So like many of the houses could be having smoke sensors. So whenever there is smoke, what happens? The sensor senses the smoke, and does the sensor makes the noise or alarm or something? Yes, alarm. But try to understand, alarm is the action. Sensor is one thing which senses something. We have to create some electronic circuitry associated with wires and connect it to that alarm bell or maybe water sprinkler. So water sprinkler or your alarm is the actuator. What action will take place is an actuator. And sensor could be like, there could be your camera is a sensor, your fire alarm is a fire sensor could be there, smoke sensor could be there, and so many other things. In fact, a normal doorbell switch which you push is the sensor which you are pushing. Fine. So the switch gets on, but if the switch is not connected to a doorbell, the bell will not ring. So sensor is working, the switch is working, and if when the someone pushes the switch and the sensor is active now, we need to take some action to the other side. Fine. So how do we take this particular action? This action is done by actuators. So this simple concept of sensors and actuators is available in our logic brick mechanism. Without writing the code, we can assign these things. So can you tell me any of the sensors that you are using with your computer? Any sensor that you are using with your computer right now? Any sensor that you are using? So your mouse is a sensor? Yes. The keyboard is a sensor. Fine. Keyboard, all the keys are sensors. right? Different keys over here are the sensors. So generally when you are typing something, when you type in something, the keyboard initializes some signal, it goes into your computer, and then depending upon what you are using, like right now, if we talk about Blender, if I press X key, it is not typing X, but it is executing some other action. So in Blender, what is happening internally is Blender is sensing the key, or internally when X key is pressed over here, the action that it tries to take is delete the object. Fine. So similarly, we have keyboard, mouse, and many other sensors are there, which we are going to work with. Fine. So the sensors will allow us to add easy movement to our objects. So how do we add movement to our object monkey? Fine. So this is the first task we are going to do today. And that is the first thing that we need for game development. So with the monkey selected, what we are going to do is, this name is Suzanne. One practice that we can do if you plan to do 3D development or anything, fine, rename these layers properly. Like this is named as Suzanne, make it say player 1. Fine, the first player, or give it some sensible name, because it becomes much more easier later on to work with them. So now with this player 1 selected, you can notice this logic area which it's showing is of player 1. Any object that you will select will have their own logic. Fine. So I'm going to add some logic with this particular person. Fine. I'm going to add some logic to this person. So what we are going to do is, we are simply going to come here and say add sensor. And what sensor we want to add is a keyboard sensor. Fine. That means this monkey will now be able to sense inputs from the keyboard. So let's see what is to be done is, this top area we don't need to do anything. In the key section, fine, what you will do is click here. It says press a key. Now I'm going to say W. People who are into gaming, they know W, A, S, D are used for movement. Or if you are normally you want to assign up arrow, just press up arrow key over here. So that key gets assigned. You can change it by clicking on it, and I can press W. That key gets assigned. Fine. Remaining things we don't want. So now what is going to happen here is the monkey can sense W key. So let's play and let's press W. Is this working? Does not looks like it is working, right? It is working. We have added the sensor. Like we place a smoke sensor or fire sensor in a building, but we don't connect the remaining part, action part, then it's not going to work. So we have decided that the monkey can now respond to W key. When someone presses W, monkey knows that W is being pressed. Okay. So now what we need to do is add some action. What should the monkey do, or what should happen to the monkey, or what monkey should do when someone presses W? Fine. This we have to associate. So this part comes with the actuator part. The central part, controllers, we are not interested right now. We will come to actuator. Actuators are something that will allow us to take some action on our object or whatever it is associated. So you will see a lot of things are there, kind of actions that can take: visibility, vibration, steering, sound, scene, and other things. And we want some motion to get associated with the monkey. Fine. So when you select motion, you will see this particular screen where it shows a lot of different kind of things. There is a simple motion, servo motion, character motion, so on. Fine. As you get into game development, you can understand the purpose of all these things. So what we are going to do is, here you can see a lot of different things is there. Location means you can change the location of the monkey. Rotation, you can rotate. You can apply some force, torque, linear velocity, angular velocity. So if you know what is force, force is like pushing something. So you give it a small push and depends on your push, gravity, friction, and every other thing, the monkey will move, slide, and it will stop probably. So that is force. Now we are going to simply get started with simple location thing. So what we want is W key is representing a forward motion. Fine. So I will rename this also as forward. Fine. You can rename this logic brick. So these are called as logic bricks. We are developing our logic over here. So we want to move the monkey forward. So what I will do is I need to know the monkey's movement. So I'll just click on this move part, and this, you see, if you see, uh, if you look at the monkey over here, fine, this green one is our y-axis. So this arrow is pointing the positive movement and this is negative movement, in the sense how the world is oriented. Fine. Now I know that this green one, if I move it this side, is positive. But so what I will do is, green means y. So I am going to add 0.05. This is location, which means 1 means 1 unit movement will take place. Fine. So I'm giving it a very small value over here. And now our motion is ready and keyboard is ready, and let's play. Now pressing W should have made it move. Okay. It's not moving. The reason is very simple. I have not connected this. It is something like you call an electrician at your place. Electrician sets up a switch and puts up your bell, but he does not connect the bell with the switch, so it's not going to ring. Fine. So switch is working, motion, what is to be done is decided, but we have not connected it. So what you simply have to do is, you see this chain type of link over here, click and drag, a noodle will come out of this, and you connect this noodle to the other one. Fine. For some reason, if you are facing a difficulty, this is not working, what you do is you add controller, and only and controller is required for us. And what you do is you connect these two here and you connect these two here. Fine. Sometimes it gives a bit of problem. You will be able to resolve that. Fine. So simply requirement is this. If it does not work, then you use this and controller and leave it as it. This part is not of our interest right now. So now if I play the game, fine. Let me scale this a bit more bigger. Okay. So very interesting. The advantage of this is that I can work on my 3D model as well as I can do my game. So I'll put it smooth. Let's make our monkey look a bit better. Now let's play the game. And now when I press W, what happens? It's moving backwards, unfortunately. Fine. Or what we understood was wrong. If we look at the monkey, with the monkey selected with this move things, see this this represents a positive value and this represents a negative value, opposite of this. Fine. Like if you take Z, this will be positive values will move it, change its location in this direction. Negative values will do it in this direction. So what we did was, we did 0.05 in this direction. So it will move in this direction because it's a positive value. So let's set it to, say, minus. So now it is in negative. Now if I play, you can see my monkey is moving very, very interestingly towards the object. And you see it's interacting with the physics. It just hits that and just slides across. And if this monkey falls down, it will continue to fall down infinitely. Right? So this is how we can add forward motion to our object. So how do we add remaining motions? How do we add remaining motions? You can make these ones smaller. Fine. Add sensor, again keyboard. Now this time I will name them properly. I will name it as right. Fine. Now for the right, I will press the right arrow. And I have to do the same thing again. I will have to say motion, and right means what? This X. Fine. So if we look at the monkey like this is the back. So this is the left and this is the right. So right means location in X axis by minus 0.05. Fine. Similarly, once this is done, connect them. Okay, so our second movement is completed. If I play forward, what happened? Sorry, forward, I had assigned W for forward, and I have assigned this for this. Let me change this. So either I use all the arrow keys or I use this. So I'll use the arrow keys. This is forward for this. So let's play this again. So my monkey can move forward and monkey can move right. So similarly, now what you need to do is to complete the movement part, you will have to assign the remaining keys. Got it? Fairly easy. Writing the code for this would have been quite complicated. Fine, but this is fairly easy. So no programming required, but just understanding of the 3D axes and how your object is and all. That is the base requirement over here. So similarly, we can finish off these remaining movements from our monkey over here, and we can have this work done. Should I show you all the remaining ones, or you have understood? This is understood? Okay, so let's do one thing now. Now, people who have played the games, they prefer to do one thing. Now, if I play the game, this is not very natural movement. It goes straight. This is quite a very fairly simple game which just has some object which moves straight, left, right. Something like this is fine. But in real life, what would happen is that we would want our object to actually turn around if it is a human kind of object or car, bicycle or something. So this standard movement is not suitable. Forward movement is fine, but this right or left movement is not interesting. So let's go back to our motion and have a look at it. And this time what we will do is we will set this to 0 location thing. And now I will go back to rotation. Fine. I will set a rotation. Now look at the monkey. Before we do anything, I want the monkey to rotate. So if I press R and Z, this is how we want the monkey to rotate. Fine. This is how we want the monkey to rotate. So when I press right arrow key, the monkey should rotate to right. When I press the left arrow key, the monkey should rotate to left. So the axis we have decided, the rotation is going to be on Z axis. This is the right arrow key. And in the Z axis, what I'm going to do is rotation is on degrees. I will put it as 5 degrees. And now when we play the game, right? Now when we play the game over here, I can move forward and okay. So this again became wrong. So we will have to go back and we will have to simply set it to minus 5 degrees. So this you can do with trial and error. So here this monkey moves. Now this looks much more sensible movement for the monkey. So similarly, you can set a left arrow key and set this to 5 and it will work. Fine. Understood? This is rotation. Similarly, we have force. Now let us see when I play this game, if notice that I will press the key and it will continue to move, and as soon as I leave the key, it stops immediately. Now, when we use the location, it is simply changing, the system is just changing the location of the monkey based on this grid or movement. Fine. So it's moving it by 0.05, 0.05, 0.05. Now I will go back to my forward movement part, and we will now set this to force, and force in negative y direction, because it's required in negative. So let's remove this location. So for a realistic game where your object has to move forward, and it has a mass and it has to interact, so if you want that kind of realism, then we use force. Fine. Torque is rotational force, so we will use force. I will simply put as -5. You will have to work around with this to see what is a suitable value. Let's start with -5. I will play. Now I am pressing this. See, its speed is increasing. I have left the key. Right? Let's try this again. Let me put this guy in a free space like this. Fine. Now I will play the game, and now I'm he see, this is what happens in 3D. That is why we need the side view, front view for understanding. And if we look from the top view, I have placed him outside my ground, so the poor guy fell down as soon as he started. Okay, so let's play this. Okay, now he's on the ground. Now I'm pressing the key. The key is pressed. Now I have left the key, and you saw that it moves and stops slowly. This is a more natural motion dependent upon your understanding. So like if the force is very high, what happens? Fine. I'll keep it to -50. Now this is not a negative or positive force. It's the force. Force is 500 only, but in which direction we are giving. That's the purpose over here. So now let me give it some force. Oh my god. So you see, a 500 force was like some dinosaur came and kicked him, and he is like gone away from that. So you will have to play around with this and test it around and see. Of course, if you are good in maths and physics, you can set the mass and all, and accordingly understand how it is going to work. Fine. Fine. So this is force. You can set some force for your object, and that kind of movement will be applied. So this is force. Then there is linear velocity, angular velocity, and you can see the basic. This way we can achieve motion. We can apply motion to our object over here and get the movement ready with our object. So what I'm going to do is, okay, we'll leave it as force, rotation 5. Let me add another keyboard over here. Or now I'm going to show you some different way of controlling the monkey. If you have any questions, you can ask. Otherwise, I will show you the management of the monkey with the mouse, or your object with the mouse. Right? Because many of the games, people who play games, they use mouse for left and right movement of the object. So this turning of the mouse that was object that is happening, it should be controlled with the mouse. And generally, most of the players, they use W key for forward, W and S for forward backward movement. Otherwise, the mouse is used for turning around the object. So should I go ahead with explanation of how to use the mouse? Okay, what is the question?
We have one question from Yogendra Pal. Can you explain that rotate part while pressing the right arrow?
Okay, so rotation, let's grab this guy. Now rotation one, when we have these objects, they have their own axis. This is axis. Actually, when we are working with the player, our axis should be set to local axis of the object, right? Local axis means that decides its xyz. See, if I just rotate it on z, fine, you can see this is the axis. This is the local axis of the object. Global axis is a representation of our whole area, like the directions north, east, west, south. So primarily, when we want to move our objects, we need to know the orientation of their axes. Right? So if I wanted to move this guy forward, I need to use the y-axis, forward, backward. Left, right, I have to use this. And z is up, down. Similarly, for rotation, if I wanted to rotate this guy based on its orientation, fine, if I wanted to rotate this guy, I will need to use some axis. So generally, these axes work like a wire that is going through the object. So if you place a wire through this object, then this object can only turn around like this, right? So you have to understand which axis is used for rotation and how it will. So if you want the monkey to turn its head left and right, so here in Blender, I'm just selecting rotation on Z axis to demonstrate to you. So this is how the object rotates, fine? If it is on Z axis. If it is on X axis, this is the rotation that will take place. So as a player, to make it look left and right, I will need a rotation on Z axis. Okay, I need a rotation on Z axis, that too local, fine? Because see, what happens is, for a car or a player over here, if you look at this player, if this player has to move forward, this is the more natural motion, the side which is it is looking towards to, right? This is more natural, forward backward. But if you move this guy globally, then on global y axis, when you will move it forward, it will move like this. So this is not suitable for a character movement of an character movement. Character movements are usually on local, and that is why you will notice whenever the motion, forward motion or motion part, you will notice that L is enabled. This basically tells that when this movement is applied to the object or rotation is applied to the object, that should take place on the object's local axis. See, I will demonstrate it to you. I have disabled local. Now if we play the game, and when I'm pressing forward or forward, it is moving in a wrong manner. This is not forward or this thing. Or no, what I did was, sorry, my mistake. Because I have set it to force, I will remove the local from the force. Now when we play this game, now see it, this is a weird, this is not a proper forward motion with respect to the player. Logically it is okay, it is moving in the Z, y direction, force is being applied in the y direction, which is fine. But for a proper movement, I want it in local axis. So this is what I will do. And now you see the force applied, it's going in the backward direction, but it is much more suitable. So that is the concept of rotation and local axis, which you have to keep in mind while working with the games and objects to make your game look much more suitable. I hope I've cleared the query.
Yes, sir.
Okay. So this is how you can set this. Now we are going to see another way that how we can trace the mouse left and right movement to movement of our object. This is quite useful for like if you have made a game with a tank and you want to move the turret of the tank, okay, or the gun of the tank left and right, then how you can get it done with that. So with our guy selected over here, fine, let's get into the top view, or let it be like this. I'll just scale this person, right, so that we can easily identify him, right? And now over here, what we will do is we will remove this keyboard movement. Only forward is kept, and forward I will set it to W, right? So we just have a simple forward movement over here of motion, which is fine. But now I want is that when I move my mouse right or left, the object should rotate left and right, just like we were giving the rotation. But now I want to do it with the mouse. So obviously now what will be the sensor for that? What will be the sensor? Can someone guess from this list of sensors? What you want to sense?
Joystick or mouse.
Joystick or mouse. So right now we want to sense mouse. Fine. So whatever, see, the simple thing is what input you want to sense, what you want to sense, and when some action takes place on that, what should happen. Now here in mouse, you will notice that it is sensing left button, which we don't want. What we want to do is we want to sense the movement of the mouse. So whenever the mouse is moving, some input should be given to this person. Now, what should this person do? What should this person do? Obviously, here this becomes a bit different. In this case, we will have to select mouse. Fine. This is a bit weird over here. It will not be motion. This will be mouse, and here instead of visibility, we will set it to look. So it's like we are telling based on the movement of the mouse, look where it is. The you can say wherever the mouse is going, try to look at that. Okay. So we will connect these. Fine. Now, which axis you want the mouse object to move? We want the object to move in a particular axis. It says which mouse axis to use, x axis or y axis. Now try to understand, if this is our screen, right? Plane, if you consider it as plain screen, flat surface, the up and down movement is called as y axis. Just like a coordinate geometry, these will be up and down will be y axis, and left and right, or this movement of the mouse which you see right now I'm doing, will be considered as x axis. This is x axis movement and this is y axis movement. We know that the mouse moves on a flat surface. Like if you are moving your mouse right now on a plane, so you either are moving it left right or you are moving it up down. So this up down movement is called as use y axis, left and right movement is called as x axis. So to move, make the monkey look left and right, I want to use x axis and I don't want to use y axis, so I'll disable it. Now the crazy concept is that when mouse is moving left and right, on which axis should the object rotate? So we have already decided that object has to rotate on z axis like this. Fine. So as my mouse will move left and right, the object should rotate on z axis, means it should look in z axis. So this is by default on z axis. We'll leave it as it is. And this is already connected now. Now if we play the game, fine, and if I move the mouse, nothing is happening. Why anything is happening? Okay, let's see. Let me set the local also over here. Let's play this. Again, this is not happening. Have I not connected it? I have connected it. Use x-axis. Mouse movement. Okay. I think I have to enable this pulse trigger over here. Fine. This will continuously send the input to the mouse. Fine. So let's try this again. Yes, now this is working. Okay. So what we did was, now our object over here, I think it's set origin to, so somehow it is passing through this particular thing. We will talk about collision later on. Okay, anyways, so this guy you can see now is able to move forward, and with my mouse movement it is moving around left and right. Fine. Now this weird thing that is happening is that I changed the size and other things of our objects. So let's try this once again. Okay, so we need to do something is called as set the collision bounds for it, and so that they can interact properly. Right now the scale and other things have been set and it's not being able to detect the collision properly. So we'll discuss about the collision in a moment, but with this particular aspect I am able to set our movement with the mouse. Fine. So what else we can do? Suppose you were having a gun type of thing, then you could use the y-axis, and y-axis movement will be translated on x rotation. So let's play this. and see what happens. I can move it like this also, and I can move it like this also, up and down. Let me disable this one, play this. Now you can see that it can move in this direction also. Fine. So this is my top and bottom movement. Maybe I think yeah, so this some orientation is now messed up with this particular object anyways. So this is how we can work with our setting of mouse and assigning it movement with the mouse. So I hope this is understood. Simple thing. Okay. So now if you have any doubts or queries, you can ask. Otherwise, I will proceed to the next part, that is interacting with other objects. That's the another part of our game, interacting with different objects over here. To like, or let's say we'll try to make a simple coin collection game. Fine. So in that case, what is the objective here is first that our for jump. Okay, for jump you can assign some value force on z axis. Fine. A key could be assigned on z axis with some force. So it will jump and then it will, because of gravity, it will come back again. Okay. Otherwise, there is a specialized setting for jump that we have this player set to actor, and when you set it to actor at that time, automatically it gets a setting for jump in motion. Here you will have to set, uh, where is that? Okay, for that we have to change the physics of the object to rigid body, and somewhere it comes, there is an option of jump also comes up. Let me see, dynamic. Yeah, you will have to set this to character motion, and then there is a jump associated with that. Fine. And jump settings are somewhere there, which I don't remember exactly, but you can set the jump directly with that key and then it works as a jump. Okay, that is another possibility, or you can simply apply the force part to it. Okay, so this is my forward movement. Forward movement, I think I will keep it as minus 0.5. Okay. Now what we want to do is we want to do something called as a collision detection. Now collision detection, the word looks like when some accident takes place or something hits other thing, uh, that is collision. But technically collision detection is that if my object is touching another object or is it in its vicinity, we can detect that. Fine. So if an object is nearby some other object touching some object, then we can take some action. So for example, in this particular one, how to detect collision between two objects. So there are two ways. One is based on the material that is applied to the object. Fine. Suppose this is an object. So let's first assign it a material. So let's create a new material over here. Okay. And let's say make it red. So let's call it and give it this material some name called as poison, poison red. Fine. So I'm giving it name as poison red, and this particular container is very dangerous. So if this guy touches this, some action should take place. So what we will do is we will, on this particular player, we will have a sensor. Now this time what we want to sense is something called as collision. Okay. Now if you look at the collision part, fine, we can detect collision, as I said, on two things. I will be discussing only one of the aspects about that today, is called as on material. You can see MP, material property. So properties are internal variable kind of things in terms of programming. Some value is associated with this object. Properties can be helpful for unique ones, and material can be applied to multiple of them and makes it much more easier to work with. So first of all, we'll set this to material, and we will select the material from the material list. Either you type in the name or select the material. So now we have set the collision. Now monkey can detect if it is around or touching an object which is having this particular material. Fine. Now what action should take place in this particular case? Fine. What action should take place? So what we want to do is, you can play a sound, you can send a message, you can do a lot of things. In this case, what we will do is, we will take here edit object. Fine. Now edit object, we will say add object, or we can say end object. Fine. So in this case, what will happen is, usually in our games, this is what happens is, once you hit this particular thing, your object will end. Fine. This is how it happens in the game. So let's play this game. Fine. And let's make the monkey move. Okay, it missed that. Let me set it in front of this guy. Right. Now let's play the game. Now when the collision takes place, you can see the monkey disappears, ends object, or the object is ended, removed from the memory. So this is called as collision detection. Now I can detect the collision with another object over here. So like we can make a shooting game, we can make a coin collection game or something like that. And in that case, like in coin collection, what is going to happen is that this object should disappear, not the monkey. Fine. So this object should disappear, not the monkey. To do that, what we will need to do? Any guesses? Where should be the collision happening? Collision concept should be added to what? Suppose these are all the coins and we want to collect these coins. How we will do that? So collision will be detected by the coins. So I will remove the collision from the monkey, and let's just add that motion so that we can move around easily to first the monkey. Where is that? Mouse, look, use x-axis. Let's connect this, and let me just see if I can move around properly. Yes, I can move around properly. Fine. Okay. Now what we need to do is, we are assuming that these are the coins. So first of all, I'll just delete these remaining coins, or let's say we have to collect the red coins. Now in this kind of logic development, there is an issue that we cannot copy paste the logic from one object to another very easily. So what we are going to do is, we are going to create this particular thing as a coin. So we will keep it here. Let me rotate it on x-axis by 90 degrees. Let me scale it a bit. Let's make it interesting. I will show you one more aspect to it. Scale it on x, or scale it on, say, y. Set. Okay. So this looks like a coin. Let's make it a golden coin, golden type of coin. So this is our coin which the monkey needs to collect. To make it more interesting, I will show you one more aspect to it. Is that we will add a sensor, something called as always. Always is like a switch which is always on. Fine. And what we will do is, so in many games you might have seen this interesting stuff. We will say, where is that? Motion, and y-axis is there, local y-axis. We will put a rotation of 15 degrees over here, and we will connect this. This is the fun part. That is how the game is going to look interesting, right? So 15, I think, is very fast. Let's make it 7 degrees. Again, all these things are your idea. So this guy is working. Now what we will do is, always means that motion will continue to work all the time. Right? So this will keep on rotating like this. Now we will assign collision over here. Now this guy needs to detect collision on property, and the property is going to be this monkey, right? This material. So that's why it is important to name your materials properly, and add action is edit object, and here we will just do a end object, right? So here this is done. Now let's try playing the game, and let's see if the monkey is able to collect the coin. Yes, we are able to collect the coin. So coin is created, it is working. And here what I'm going to do is, now I'm going to duplicate this. If you remember last time, people who were there, I had explained you duplicate. If you do a shift D or duplicate your object, it will copy the logic also over here. So I will do a shift D and I will place the coin over here. Fine. And let's get into this and let's play the game. Okay, so let me collect the coins. It seems it collects it only at a particular certain angle and not all the angles. So I am able to collect the coins. Quickly we have to collect all the coins. So here we can collect the coins. Fine. Okay, so this way I can collect the coins. We can add more logic to it by counting how many coins are done. We can have the logic of let us say, what do you call it, timer can be added, and all those concepts are there that can be done over here. It's possible. Fine. So these are the this is another basic thing over here. Let's see if we can get a sound associated with the coin, and let me just check if I can get a sound. Just give me a minute. I will just try to get one sound downloaded. Okay, let's just try adding a sound to it whenever uh, we collect a coin. Fine. So let me first save this also, and okay. So now when collision takes place, we want to play the sound also. So I don't need to have another collision over here. Fine. So what we will do is, we will say sound. Two actions can take place on the collision, and I will just connect it from here. Okay. So when collision takes place, object will end, and this thing, I'll move it upwards, and let's say we have this ding sound, and volume is, let's increase the volume to 2, play stop, and hopefully this should work. Fine. Let me see. So the sound did not come, but sometimes what happens is, because this object is ending, the sound also does not work. Fine. But in which one did I add the sound? That is also the question. We added the sound on this. So you have to keep the logic done beforehand, because these ones are the copied ones. This logic will not get copied later on. Only the one that was initially there, that logic gets copied. Let's see. The sound was in this. No, the sound did not come. Most probably because the object is getting ended, and then this is there. Okay, but this is a possibility. We can work around it. Play end, play end. Let's see. Let's try once again. But most probably this sound is not coming because the object is ending and this logic is also going away with that particular object. So let's try one thing. What we'll do that is with monkey. When monkey hits that object, let's say add sensor collusion, because monkey is not going to have end. uh, okay, now this is yellowish, so poison red, and here sound, let's say this sound. Let's connect these two things. Fine. Let's try this again. Now in this case, whenever the monkey hits or this collision takes place, the sound should play, but it's not playing properly. I'll have to check it out. There could be some issue with the version or something like that. I hope this sound which I downloaded is working. Sound is working, but here it is not showing up. Or let me try one more thing. Sometimes, okay, let's try it in this. You can start the game separately also completely. It will start some separately also. Let's try this. No, the sound is not working. So I'll have to check what's the issue for this anyways. But technically this sound should play when this monkey hits this material. Fine. This particular material, that is, yes, poison red, but unfortunately it's not playing the sound. Play stop is there, play end is there. Let's try this one also. Now it is playing play end. So now we can have the sound also, right? Oh, he fell down. Okay, so this way we can add sound also, right? Some aspects are there. You can search about it, what exactly they mean. So you can add sound on different actions, but you will have to keep the points to understand. Like if this object ends, then all the logic of the object is also removed over here. So I have added the logic to the monkey because monkey is not ending, and we are playing the sound when monkey this things. So this way we could add the sound also. Okay, any doubts or queries if you have now at this point? So this is how you can add the logic. And the last very interesting aspect that I want to show you is called as the first person view or first person shooter games, where it gives you a feel that as if you are looking from the player's eyes or from inside a car or aeroplane's cockpit or something like that. How do we achieve that? So generally what will happen is this game, when you compile it or play it, usually will start from this camera which is there. So first thing is that we need to place the camera properly. Fine. So I'll go to the view, lock camera to view. So generally what happens is the camera will show you the content. Fine. So when I play the game, the games will usually look like this. Now this is okay for a simple game or something, but the game will look very interesting if I could see from how the monkey is looking at. things, fine. So if we place a camera somewhere above the head of the monkey or something, that way we can have our first person view. Like if you have created a car, you will place one camera inside the car. So right now what we will do is, first of all, we will place our camera, fine. We will place this particular camera somewhere near the monkey, fine. And if you were there in my Blender session, we do that here. I'll scale this guy a little bit smaller. I hope we'll be able to grab the coins one. Okay. So what we need to do is, with the object selected, what I will do is, this is the front view and this is the back view. I'll place the camera somewhere here. So Control Alt 0 brings the camera here. Right? The camera is locked to the view. I will set the camera somewhat like this. Okay. So now if you see, the camera is placed somewhere which is like fairly suitable for the view, or if you want, you can grab the camera and place the camera here. Let's see what we see. So this looks like as if we are looking from the monkey's view. So once you find that the camera is in a suitable location, okay, it could be far off, but it's in the suitable location. Otherwise, we will have to go to the camera properties. Like, let me grab the camera. Exactly, like if you want to place it somewhere here or something like this. And if we go into the camera view, I cannot see the monkey head. So we will have to go to the camera settings here, camera, and you will have to set the focal length. Change the focal length and you will get to see this thing, fine. Something like this. So, but since the camera is set to perspective, you will get a different view. So we will set it to perspective and we'll just leave the camera a bit outside the object. Fine. I think this is suitable. This is a suitable view for the camera, right? Now I can play the game, but the only thing is my object will move and the camera will not move. So what we need to do is, we need to do something called as a parenting. Fine. So in parenting, it is child follows the parent. So what we need to do is, we need to select the camera. We need to select the parent. Okay. And then we press Control P. No, either of it is there. So let's see what I did first. I selected the parent, child. So child, parent, Control P, and say parent to object. Now if I select this and if the camera is moving, then the parenting has happened properly. That means when my object will move, the camera will also move over here. Okay. So the parenting is done. What we did, let's try to guess that again. Select the child. Child follows the parent. So select the child, select the parent, Control P, object, and select this object and move it. If the camera moves, your selection process were correct. So child, parent, Control P, and you can press Alt P if it has gone wrong to clear parent also. Fine. So for that, you will have to select the camera and clear its parent and do it again. If you move the camera, you will see that the parent does not move. It's a natural system. You know that the child follows the parent, but the child could be running here and there without the parents also. So anyways, uh, jokes apart, now this is done. Now what you need to do is, you need to simply start your game from the camera view and you play your game. And now what you have is a first person view over here, right? Coin collected, coin collected, coin collected over here. This is also done, and this is done, this is done, and This is done. Okay, so this is how you can set a first person view. Sorry, my camera is in the lock mode, so it will keep on moving. Fine. So this is first person view. Many of you might have played these games. So parent the camera, uh, uh, make the camera the child, and then you get the first person view. Okay, clear? Any doubts on this aspect? This is our first person view. These whatever I'm discussing today are the primary things that are required in your game development part. So we have discussed about the basic movements, collision detection, first person view over here. Now if you wanted a third person view in this, so for that we will have to write some logic. So let me demonstrate that to you. So what is a third person view? Third person view is like our camera will be set over here. Let's, for that purpose, one camera is already there, so we will say add camera. In this case another camera is set. Now with this camera selected, if I press 0, what happens? It goes to this camera. So what we will do is we will have to first set this camera as the main camera. Where is that option? Select camera, set active object as camera. So now this camera is selected. Fine. Now what I will do is I will set this camera to a specific view like this. Fine. So this is my third person view. This again, this one I will go to view, camera, set active object as camera. So this is my primary camera now, and that is the other camera. This is our second view which we have. So now what we want to do is that we want to switch between these two views, the main camera view and the other camera view. So we will need to add some logic to this. Fine. So with monkey selected, we can add the logic to the monkey. It's not necessary that the logic has to be on monkey. The logic can be somewhere else also, but let's do this. So what we will do is we will add a keyboard over here, add a key C. Fine. When someone presses C, we will shift the camera, add an actuator, and here in which one it is, there is camera, and here we will set this camera 1. No, I don't think it is this one. Okay, let's try this. Now if I press C, it did something, but did it fall down? Just a second. This is not there. Their actuator is in scene. Yes. Set camera. Okay. And camera second should be set now. Fine. When I press C, it should set to the other camera, and I will add another sensor for keyboard so that I can set it back. Here I will say Shift C. Right? Sorry, I will say C, and first modifier is going to be Shift. So if I say Shift C, left Shift C, I will be setting back to the regular camera. We'll go back to the scene, and over here set camera, and this time we'll set it back to the other camera. Okay, so hopefully this is going to work now. Now here this controller is not getting connected. This happens sometimes. So let's say and okay. So this is how we can have a third person view, but for this purpose the game has to start from the first camera. Let's play this. Now if I press C, I'm shifting to the other camera, and if I press shift C, I can switch back to the other camera. So here we can move around, play the game. Fine. Okay, and then I can press C or shift C to switch back to the other camera view. So here this thing is there, so I can shift between cameras. There is one more logic that I could use the simple C key to toggle between the cameras, but that will require me to write some more, add some more logic over here to get it done. But overall, the point is that without writing any kind of code, but using basic understanding logic, like what is to be done when I press C, what I want to do, you simply have to connect these values. So even if you don't have any programming background, you can still work with or develop some games with this. So that's the idea behind the basics of UPBGE, or a game engine environment which can help you develop the games. So there are other game engines like Unity, Unreal, and other things where people develop games, but they don't have the 3D environment in them where you can immediately edit or change the setup or something. You have to import all your objects beforehand into that and develop your game over there. With UPBGE, we can develop all the games directly over here. Of course, today the workshop was at a very basic level, so it is not that the games are going to be very simple. Yeah, of this manner we can go to, if you go to upbge.org, you will find some demo games over there which were created by UPBGE. Let me see if we can find something. So here on UPBG's website, you can see this particular demo game is shown over here. Fine. You can, another demo game is shown over here, something like this you can make. This is all about the graphics and other things that you can use in your uh, game. Fine. So what difference it makes is, see, the logic here is same. The person is shooting something, some object flies and touches other thing. So there is, what we are going to do is the collision detection, and then some explosion takes place. So you saw that edit object, we can add an object over there which should be animated, and it will show the blowing effect, add the sounds and other things. So this simple looking game which we have made has the same logic of this particular one which we just saw over here, this one. Fine. This is the first person view, a gun is being shown, and in our game what we are seeing here is the head of the monkey. Okay, so the another part of the game is that how good the graphics are and how you have implemented them. They are using the same simple logic in the background itself, but the biggest difference is the sound and the graphics, color, lighting, and all these things make a huge difference how your games are going to look like. So that was a small brief overview about the concept of game and game development over here. If any one of you is quite interested in game development, then the word of advice is that you have to eventually start working with some programming. So this game development environment has a scripting section where I could write some logic over here and reduce the whole code. Like what we noticed was that for the movement, forward, left, right movement and all, we have to do all the work manually again and again. So if you are into programming, you could reduce it to a small piece of code, and that could be directly associated with that. And coding also gives us a better control over the game development part and all. So here Blender and of course UpBGE, this game development engine, supports something called as Python scripting, also Python programming. So if you know Python programming, then you can develop more complex games in a much more easier manner. So that's the idea behind the game development. So I hope you enjoyed today's session. uh, the forum is open. You can ask any questions or anything that you might want to ask, or if there is any confusion remaining, then we can discuss about that. Can
Yeah.
we can we install it in mobile also? There is another question over here. Yes, you can export your game, but I'm not sure if it can be sent for mobile. But as far as I remember, yes, it's a possibility. But are you asking about installing UpBG on mobile or the game in the mobile? Yes, so game can be exported to be played individually as an executable, but I have not tried it for mobile. But somewhere I have read some reference, yes, that it is possible to export it to a game also, as for the mobile purpose, Android at least. Okay, thank you. So, any other doubts or queries? Okay, then. So, we will end today's session. It was nice having you. I hope you people enjoyed the session. And I'll think of some other sessions for upcoming weeks, and we'll work on that. You can visit my YouTube channel, and as usual I'll ask you to subscribe to my channel. There are a lot of videos on different topics which I work upon. 3D, I have already last week I created a 1 hour 3D this thing, introduction to Blender, so you can go through it. There is a detailed one also which I'm working on, and I'll be working on one small, I'll develop for this game thing also, which we discussed today, introductory one for the game thing, and I will release it on my channel also. So I hope you enjoyed the session. Thanks for joining in and giving your time, and hope to see you for other sessions also, upcoming sessions. If you are on the WhatsApp group, you can suggest, or we can also come together and take up some topics if you would like. So that's it for today. Thanks for joining in.